Hey there, I'm Steve Trout. I'm a tech writer on the Go team. Today I'm going to show you how I can install Go and write a bit of code. Along the way, I'll talk about modules, which Go developers use to manage dependencies. And I'll finish up by writing a simple web service, which is one of the things Go does best. So let's get started and install Go. I'll visit the Go homepage at golang.org and click the Documents link, and then Installing Go. Now this page includes a button I can use to download a file to install from, along with installation instructions. If the download isn't what I'm looking for, I can click the other downloads link to scroll for a file that might be a better fit for me. But I'm going to click the great big button to download a file to install. And once it's downloaded, I'll open it to start the installer. All right, and click continue. And it's telling me how much space Go will take up on my disk after I've installed. I'll click install. And it prompts me for my password. And then the installer begins running scripts to install Go. This takes about a minute or so. It's downloading files from the Go site to my computer, and it's running scripts to update paths on my computer so that I can run Go commands from the command line. And once it's finished, Go is installed. I'll be using the command line for this demo, but there are several editors and IDEs that support Go. If you like an IDE, be sure to check out the talk by Julie Q and Rebecca Stambler. So in my command prompt, I'll run the Go version command to confirm that Go is installed. The output tells me Go's release version along with the OS it's compiled for. And now I'm ready to write some code. I'll start with a Hello World app. First, I'll create a directory in which to keep the code. And I'll cd in there. And then I'll create a file to put the code in. Today I'm using Sublime Text. So I'll save it into the directory I just created and call it hello.go. All right, so all Go code needs to be part of a package. A package is the primary group in which you organize the functions you write. So I'll declare a package first. I'm calling this package main because any Go code you want to execute on its own has to be in a main package, and I want this to run independently. Writing an executable program in Go is easy. There's a specific convention that Go follows. Create a package called main and put a main function in it. In a main package, a main function becomes your application's entry point. So I'll create a main function. All right, so next I'll import the fumped package. Fumped is short for format. The fumped package contains functions for reading and printing text, and it's just one of more than 300 packages in the Go standard library. I'll be using a function in the fumped package to print my greeting. So inside my main function, I'll call fumped println. So Go has great support for great native support for Unicode, so I'll get a little bit clever here. Instead of using text for my greeting, I'll grab a couple of emojis and paste them into my code and use those. This looks like a hello wave. And looking for the world. There it is. Copy that and paste that in as well. So this should be all the code I need. The quickest way to run Go code in a simple setup like this without an IDE is to use the go run command. So I'll type go run hello.go. And it's an emoji hello world. I'll make it a little bit more interesting in a minute. But first I want to say a bit more about a couple of the things I just introduced. You saw me use the go run command to run a main function in a main package. Earlier, I used the go version command to confirm that Go is installed. Those are just two of many Go commands that you might find handy. Here are just a few more. You could run go build and go install to compile your code to a local binary. You can run go test to test your code with Go's testing framework. And go get is a commonly used command to download source for your code's dependencies. I'll show that later when I use code someone else has written. For the full reference on commands, check out the golang.org website, where the commands are organized according to things you might want to do. I also want to say more about how Go code is organized and distributed. You write code as functions, and you collect related functions into packages, and you collect related packages into modules. If you want to make your functions available to other developers, you publish your module so that it's visible on the package discovery site. As a Go developer, you have access to lots of other packages and functions you can use in your own code. That includes the hundreds of packages in the Go standard library. Those are listed on the package discovery site at package.go.dev. But you can get even more packages written by other developers. Their packages are available alongside the standard library. You can search for a package you might want to use, packages for adding features related to databases, security, encryption, and so on. Right now, I just want to show you how you can use a package you found. So I'll search for one I already know about. I'll look for the quote package. And this RSCIO quote package is the one I'm looking for. So that quote package was written by Russ Cox, one of Go's designers. I know Russ does good work, so I'm going to give that one a try in my code. From the list of functions in the package, I can see he's got a hello function that returns a friendly greeting. And here at the top of the page, I can see that Russ's package is in a module called rscio.quote. On the versions tab here, I can see a list of the versions for this package in the module. Each of these represents a tagged version of the code in Russ's repository. Go modules use the semantic versioning model. A version number includes a major part, a minor part, and a patch part. A major update includes changes that aren't guaranteed to be backward compatible. Those might be changes to the module's public API, for example, things that break code that's already using the module. A minor version update is guaranteed to be backward compatible, but it also could include changes to the public API, such as adding new functions. A patch update is guaranteed to be backward compatible and is for bug fixes. So let's look again at the V1 versions. Let's look again at the V1 versions. V100 had a single function in it. V110 is a minor release, so it added another function without breaking backward compatibility. And it was the same for V120, which added a third. V121 is a patch release, so no changes to the public API, but it's a bug fix release. And down here, V2 and V3 are major version updates that don't guarantee backward compatibility. This versioning scheme helps you keep your code stable. You can upgrade in a deliberate way, knowing the risk. So now I'll try out the package. I'll copy the package path up here at the top of the page. And now I've got it so I can paste it into my own code in an import statement. And import rscio quote. All right, and in my main function, I'll call Russ's quote hello function. I'll replace what I'm doing there with the emojis and add a call to hello. All right, so now I'll put my code into its own module. Having it in a module gives me a way to manage its dependencies, like this quote module I just added. I'll show you how in a minute. I'll add my code to a new module by running the go mod init command. And for the command's argument, I'll give it a location in my Git repository, because that's where I'll eventually keep my code. This becomes my module path, and it's part of a unique identifier for my module. And now I'll run the command. So the command created a go.mod file. Let's take a look at that. The file gives the version of Go I'm using as the minimum required version for my module. Also at the top there's that Git repository location, and that's now my module path. If I decide to publish my module for other developers to use, that module path is how Go will find my code to download it when they need it for compiling. For example, I'm now importing the quote package, but I don't yet have the package's code to compile with. To get it, I'll run go get, that go command I mentioned earlier. So Go went looking for source for the packages I'm importing. The command downloaded the latest version of Russ's quote module, which for v1 is 152. It also made a change to my go.mod file. The file includes this required directive down at the bottom now, and that directive says that my module requires the quote module at a minimum version of 152. Now I'll run my code again. All right, so that's Russ's hello function printing hello world. So this is a common sequence in Go. You start some code and create a module. If you need it, you find a useful package, and then you run go get to get source code to build with. The go.mod file helps me manage my dependencies. In that required directive, if I change the quote module's minimum version to 150, Go will downgrade the dependency. It's the same for upgrading. So I got Go installed and I got hello world running. I put my code in a module and I started using an external package. I'll finish up by showing one of the things Go does best. I'll make a hello world idea and turn it into a web service. Web-based apps are some of the easiest to build with Go. That includes HTTP servers and web services. I'll change my code so that when someone makes a call to a specific URL, I'll return JSON with the hello world greeting in 3 languages. I'll start by declaring a struct to hold the response data. A struct is a collection of fields, so it gives me a way to group together my greeting text, the language, and a language code. Notice those string literals in the text, the green text there. Those are called struct tags. Each one specifies the JSON field name that will be used in the output, the response value. That gives me a way to ensure that generated JSON fields have lowercase names. Otherwise, Go would use the struct field names, which are capitalized. In Go, you capitalize a field or function name when you want it to be visible outside the package it's in. In this case, the Go code outside my package that creates JSON from my struct needs access it can only have if the field name is capitalized. Lowercase field and function names aren't visible outside the package. Next, I'll declare a slice to hold the multiple greetings. A slice is a Go array whose size changes as I add and remove items. This slice gives me a way to collect multiple structs, one for each language. Now I need a function to do something when the requests come over HTTP. So I will add a handler. I'm adding a hello handler function whose parameters represent the request and the response I'll create. Both the response writer and the request type are part of the HTTP package that's in the Go standard library. The HTTP package is one of the reasons it's so easy to write web services in Go. It includes functions for making requests over HTTP methods, handling responses and headers, and other low-level aspects of HTTP. Check out the talk by Julie Q and Rebecca Stambler for more about using the package to set up a web server. Inside the handler function, my handler function encodes the contents of the greeting slice into JSON for use as a response. To do that, it uses an encoder type from the JSON package, which is also included in the standard library. And I'm using setIndent to set an indent string, so the response is a little bit nicer to look at. Before I finish the code, I want to mention the := operator I'm using here. You use it to declare a variable and assign it a value in one line of code. You don't need to declare the variable's type. Go figures that out for you. I like it because it's a great example of how Go's design keeps things simple and uncluttered. Now to put it all together so the service starts when I run the code. I'll update my main function and replace what I was doing before with this. So I'm calling handle func to map a URL path to the handler function I just wrote. When a request comes in on /hello, the hello handler function will be used to handle the request. Then I'll call listen and serve to start a server that listens on port 8080. Ordinarily, listen and serve just starts and runs without returning a value, but if it returns an error, I want to handle that. The fatal function will, in the standard library's log package, will log the error and exit. Now I'll run the code. Go run, hello.go. Okay, so apparently I'm not quite finished yet. It looks like this command's output tells me that I'm importing 2 packages that I'm not using and trying to use 3 packages that I'm not importing. So I'm importing fumpt and rsciO quote and not using them. And I'm trying to use HTTP, JSON, and log. So let's take a look at the code here. Here's where I'm commenting fumpt and quote. So I need to update my imports to account for that. So let's fix that by pasting in some new imports. I'm going to combine the imports into a block using a single import statement. This is something I could have done earlier. I just didn't. So now I'll try to run the code again. I feel a little bit better about it this time. Okay, so the service is now running. I'll open another command prompt to try it out. And I will curl localhost 8080 hello. All right, it looks like it's working now. So I've got JSON, a snippet of JSON with my hello world messages in 3 languages. And I got this going by using only packages from Go's standard library. There are external packages that have more web service features and might be as easy to use. If I wanted, I could find those using the package discovery site. So that's all I have to show today. You can find lots more about Go at golang.org, go.dev, and all over the web. If you're interested in support for Go in editors and IDEs, as well as Go's package discovery tools, be sure to check out the talk by Julie Q and Rebecca Stambler. Thanks for watching.